In today's class and video, we are going to look at paper chromatography as a separation technique. So we'll start our introduction by looking at what paper chromatography is. Paper chromatography is a chromatographic technique used to separate and analyze a mixture using a cellulose filter paper trapped with water molecules as a stationary phase and a solvent mobile phase. Its application. Paper chromatography is often used in educational settings to demonstrate separation techniques. It is also used to analyze food dyes, plant pigments, amino acid, and other colored substances like ink. So let us look at the chromatography paper. So from this picture over here, these are the various forms that the chromatography paper can be. So it's either in this form, or it comes in a form of a strip like this, or it comes in a roll form. So chromatographic paper is a cellulose filter paper made from cellulose fibers, which are polymer of glucose. And the cellulose fibers have OH groups that sticks out, giving the paper a similar surface to silica and alumina. And the paper also contains water adsorbed to the cellulose. Cellulose filter paper is used in chromatography as a stationary phase because it's chemically inert, it's pure, it has a wide range of pore sizes, and it's also compatible with many solvents. So these are the properties or the characteristics of the cellulose filter paper that makes it good to be used as a stationary phase in the chromatography process. How paper chromatography works. So paper chromatography works by utilizing the differential partitioning of the components between a stationary phase, which is the cellulose filter paper, and a mobile phase, which is the solvent. So before we look at our example, I just want us to look at this two setup over here. So the first setup is a setup for the beginning process of our paper chromatography, and the second setup is the chromatogram, or the obtained results after running the chromatography process. So from the first setup, so we can see that this is our chromatographic chamber over here, and this is the cellulose filter paper, which is acting as our stationary phase, and which is a polar material. And this is a piece of wood with a clip that is used to hold this stationary phase upright in the chromatographic chamber. This is also our solvent, which is acting as the mobile phase, and this is the spotted sample spot, which is the mixture. So from the second setup, which is the chromatogram, so these are the various separated components in the mixture. So we have 5 separated components. This is the first one, second, third, fourth, and the fifth separated component from the mixture, and this happens to be our solvent front, which is the distance traveled by the mobile phase through the stationary phase to separate the various components of the mixture. So now let us look at our example. So if a small amount of a mixture is spotted on the paper, so this is the spotted sample, and the paper which is acting as a stationary phase, and a solvent is allowed to travel up the paper by capillary action as shown in the chromatogram over here. What happens is that the different component of the mixture will be carried by the mobile phase at different speeds and rates depending on their adsorption, polarity, and solubility. And these, as a result, will cause the components of the mixture to separate into distinct bands or spots on the paper. So from the setups over here. So we can say that the stationary phase, which is the cellulose filter paper here, is a polar material. So in terms of polarity, what we have to note is that the most polar component in the mixture will have the strongest affinity for the polar stationary phase, hence will absorb the most onto the stationary phase and will travel the least in the mobile phase through the polar stationary phase, and this will result in the smallest RF value in the chromatogram. On the other hand, the least polar component in the mixture will have the strongest affinity for the mobile phase and will be soluble in the mobile phase the most, hence will travel the farthest through the stationary phase with the mobile phase, and this will result in the highest RF value in the chromatogram. So from this chromatogram over here, so we can see that this component is the most polar component, the most absorbed component onto the stationary phase, and the component with the smallest RF value. On the other hand, this separated component over here is the least polar component and the most component soluble in the mobile phase with the highest RF value. So let's look at the test procedure or the steps for the paper chromatography. So one is to equilibrate the chromatography chamber, and to equilibrate the chromatography chamber means to saturate the chromatographic environment where the chromatography process takes place with the mobile phase. So two, using a pencil, draw a straight line across the paper about 1 to 2 centimeters from the bottom edge where the sample will be applied. So from this picture, this is the bottom edge of our cellulose filter paper over here. So we measure 1 to 2 centimeters from the bottom edge and draw our baseline with our pencil over here nicely. And what we have to notice that the baseline, which is drawn with pencil, is insoluble in the mobile phase, so will not affect our result. So when we are done, the third is to apply a small volume of the sample solution, which is our plant extract, to the baseline using a capillary tube or a micropipette, so as seen over here. So this is the capillary tube which is being used to apply a small volume of the plant extract onto the baseline. And one thing that we also have to notice that if you want to apply 2 or 3 spots on the cellulose filter paper, we have to ensure that the spots are evenly spaced out as shown over here. So this is the first spot, second spot, third spot, and fourth spot. So we just have to ensure that they are evenly spaced out for better separation. So the next is to open the lid of the chromatographic chamber and dip the stationary phase with the spotted plant extract into the mobile phase. And one key thing that we have to note here is that the solvent or the mobile phase in the tank should be at a level below the application line on the paper. So once we are done with that, we place a glass rod over the chamber and tape or clip the paper to it, ensuring that the paper base just touches the solvent without being subject. And after that, we cover the chamber to maintain a saturated atmosphere. So the fifth is to allow the solvent to slowly travel upward through the paper until it reaches the determined solvent point. And at the determined solvent point, the various plant pigments in the plant extract will separate well. So once the solvent front is reached, we carefully remove the paper from the chamber and mark the solvent front and allow the paper to air dry completely. And lastly, we analyze the chromatogram by calculating the RF value to identify the different components of the sample mixture or the plant extract. And what you have to note is that each spot on the chromatograph represents a different pigment or component of the plant extract. So this is our chromatogram over here. So the line over here happens to be the solvent front. And for this chromatogram, this is the first separated plant pigment, second, third, fourth, and this is the fifth one. So this is how our chromatogram is going to look at in our experiment.